Welcome back to series of lectures on digital logic design. This is Dr. N. Veeranjaneyulu, Professor, Department of IT. In this session, we are going to discuss about decoders and encoders. This is Unit 3, Session 4, Decoders and Encoders. First of all, what is decoder? What is the objective of this decoder? See, a decoder is a combination circuit which takes n inputs and produces 2 to the power of n outputs. See, this is decoder. A decoder is a combinational circuit that converts binary information from n inputs to a maximum of 2 to the power of n unique output lines. This is the definition for decoder. A decoder is a combination circuit which converts binary information from n input lines to a maximum of 2 to the power of n unique output lines. If the n bit coded information has unused combinations, the decoder may have fewer than 2 to the power of n outputs. Here the maximum of 2 to the power of n input. If the unused combinations are there, the decoder may have fewer than 2 to the power of n outputs. That is why maximum of 2 to the power of n outputs. So, suppose we will consider one decoder, that is 2 to 4 line decoder. It takes 2 inputs and produces 4 outputs. This is 2 to 4 line decoder. See, the decoder is called n to m line. Okay. Here the terminology is n to m line decoder, where m is less than or equal to n. The decoder is also used in conjunction with other code converters such as BCD to 7 segment decoder. Now, the example is this is 2 to 4 line decoder. See, now another example is 3 to 8 line decoder. This is, it takes 3 inputs and produces 8 outputs, and 4 to 16 line decoder, 5 to 32 line decoder, like that we have so many decoders. So, now we are going to discuss in detail about 3 to 8 line decoder. For each possible input combination, there are 7 outputs that are equal to 0. 7 outputs are equal to 0, only one that is equal to 1. It takes 3 inputs and produces, it produces 8, but only 1 is the output. So, for each possible input combination, there are 7 outputs that are equal to 7 outputs are 0 and only 1 that is equal to 1. So, this is the logic diagram for this decoder. Logic diagram means here x, y, z are there, See, what are the combinations for this? See, here the combinations are this is x, y, z, that is first decoder D0 is equal to x bar, y bar, z bar, and D1 is equal to, that is x bar, y bar, z, and D2 is equal to x bar, y, z, x bar, y, z bar. So, x bar, y, z bar. Like this, D7 is equal to x, y, z. See, based on the combinations, so x, y, z are there, D0 the outputs are 3 inputs and 8 outputs, 3 to 8 line decoder. So, the combination is, so what are the inputs for this? X bar, y bar, z. This is x bar, this is x bar, this is y bar, and this is z bar, x bar, y bar, z bar, like this. This is the logic diagram for 3 to 8 line decoder. See, the truth table is, this is the truth table. If the values of x and y, x, y and z are 0, 0, 0, the D0 is is the output. The D0 is the output. If the values of x, y, z are 0, 0, D0 is the output. Okay. At any point of time, only one output is active, that is D0 is active when the inputs of x, y, z are 0, 0. If the inputs of x, y, z are 0, 0, 1, this is active, D1 is active. If it is 0, now this one, like this. If the inputs are 111, the output is this one. Okay. This is the truth table for 3 to 8 line decoder. It takes n inputs and produces a maximum of 2 to the power of n outputs. This is 3 to 8 line decoder. And next we are going to discuss about decoder with enable input. In general use, we are using this decoder with enable input only. Here, this is the some decoders are constructed with NAND gates. We know about NAND gates. These are all universal gates. Okay, NAND gate is the universal gate. Okay, by using these gates, we can build any type of circuit. So, some decoders are constructed with NAND gates. It becomes more economical, yes, to generate the decoder minterms in their complemented form. So, complemented form means, as indicated by the truth table, only one output can be equal to 0 at any given time. Only one output equal to 0 at any given time. All other inputs are equal to 1. So, here this is decoder with enable input. This is decoder with enable input. Here, this is 2 to 4 line decoder only. Here, the values of these AB are the inputs and these are the outputs. These are the inputs and these are the outputs. So, here this is enable input. If the enable input is 1, whatever may be the values of x, y, z, AB, okay, the outputs are 1, 1, 1, 1 only. If the enable input is 0, that means the decoder, see the values of AB are 0, 0, this is 0, 0, 1, this is 0, like this. This is enable input. Here, this is enable input. Based on this enable, if the enable input is 0, then the all inputs are equal. See, as indicated by the truth table, only one output can be equal to 0 at any given time, and all other inputs are equal to 1. This is a decoder with enable input. And now, what are the advantages of this decoder, that is applications of decoder? Where we are using these decoders? Okay, these decoders are used in microprocessor memory systems. In memory banks, to select memory banks, okay, in microprocessor or in microcontroller, to select memory register banks or memory banks, we are using this decoder, that is selecting different banks of memory. And another application is microprocessor input and output systems. Input and outputs, selecting different devices, different input devices or output devices, and microprocessor instruction decoding. Okay, in 8086 or any microprocessor, any architecture, we have instruction decoding. Okay, that is instruction decoding will be there. That enabling different functional units. To enable different functional units, we are using this decoder. And in memory chips also, enabling different rows of memory depending on address. Depending on address, okay, enabling memory address lines. Okay, for that purpose also we are using decoders. These are the applications of decoders. Now, we are going to discuss about see this is not demultiplexer. This is a decoder with enable input is called will act as demultiplexer. So, this is demultiplexer. A decoder with an enable input is referred to as a decoder or demultiplexer. A decoder with an enable input is referred to as a decoder or demultiplexer. The truth table of this multiplexer is the same as with a decoder. It takes, as usual, it takes 2 inputs and produces 4 outputs. This is enable input. So, a decoder with enable input is also called as demultiplexer. Okay, we will discuss this demultiplexer in detail. Okay, this is now this is one example. This is a 3 to 8 line decoder with enable implement the 4 to 16 line decoder. That is, by using two 3 to 8 line decoder. Okay, now we have available only, we have only two suppose 3 to 8 line decoders only. We need to design a 4 to 16 line decoder. How to do that one? By combining these two 3 by 8 line decoders, we can build, okay, 4 to 16 line decoder also. So, this is the mechanism. So, this is 3 by 8 line decoder, okay, this is one and this is another one. So, how many inputs will be there for 3 by 8 line decoder? 3 inputs x, y, z, and for this also 3 inputs x, y, z. Here the another input is there, that is w. This is enable input. This is, if this is 1, okay, this decoder is inactive, and if it is this is 1, it 0 goes to this decoder is in disabled state and this decoder is in enable state. If the value of w is 0, this first decoder is in enable state and the second decoder is in disabled state. So, how many inputs are there? Total for 3 to 8 line decoder, 3 inputs and 1 enable input. For this, 3 inputs and 1 enable input. Overall, how many inputs are there? This is, consider this as like this. How many inputs are there? 4 inputs, 1, 2, 3, 4. And how many outputs are there? 16. This is 4 to 16 line decoder. See, by using small decoders, we can design larger decoders also. That is, this is the 3 to 8 line decoder with enable input to implement 4 to 16 line decoder. And next one is, see, by using decoder, implementation of full adder with a decoder. See, we can implement, okay, a full adder with a decoder also. What is full adder? A full adder is a combination circuit which adds 3 bits at a time. Okay, 3 bits. Suppose 3 bits are x, y, z, 3 bits are x, y, z, x, x, y, z. Okay, suppose what are the outputs? Sum and carry. Suppose this is 0, 0, 0, okay, we have the like this. So, sum is 0, 1, 1, 0, 1, this is 1, 0, 0, 1, 0, 1, 1, 1. This is the truth table for this full adder. So, what is the expression for S? S is equal to 1, this is 1, 2, 4, 7, this is 1, 2, 4, 7, and C is equal to 0, 1, 2, 3, 5, 6, 7, 3, 5, 6, 7. So, see how many inputs are there? 3 inputs. Okay, how many? See which decoder we have to use? 3 to 8 line decoder. This is 3 to 8 line decoder. This is 3 to 8 line decoder. So, this is 3 to 8 line decoder. So, how many inputs? X, Y, Z, 3 inputs. This is how many outputs? Okay, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7. Total 3 by 8 line decoder. So, the numbers are 1, 2, 4, 7 for S. S 1, 2, this is 4 and this is 7. These lines are connected to this is S. And what about carry? Carry is equal to 3, 5, 6, 7. So, this is 3, 5, 6, 7. These 4 lines are connected to this is C. And this is the implementation of a full adder with decoder. By using 3 to 8 line decoder, okay, we have implemented this full adder. Now, next one is, see, now we are going to discuss about decoder, encoder. See, what is encoder? this is reverse of this decoder. Decoder, what is decoder? A decoder is a combination circuit which takes n inputs and produces a maximum of 2 to the power of n outputs. What about encoder? Encoder takes 2 to the power of n inputs and produces n outputs. So, this is an encoder is the inverse operation of a decoder. We can derive the Boolean function by table. This is 4.7. How many inputs? 2 to the power of n inputs. Suppose if it is 3 to 8 line decoder is a conversion, 8 to 3 line encoder. This is 8 inputs are there and 3 outputs are there. Here the values of the D0, D1, D2, D3 like that. D0 is equal to 1 and the inputs are X, Y, Z. Okay. And if it is D1 is equal to 1, then the input is the output is 0, 0, 1. And the expressions for X is, see for X is equal to here 4, that is D4, that is D4, D5, D6, D7, okay, that is X. And what about Y? Y is equal to, see here 0, 0, here 0, 0, that is D2, D3, D2, D3, D2, D3, D6, D7, okay, D6, D7, okay. And what about this one? Z is equal to D1, D3, Z is equal to this one, this one, this one, this one. Okay, Z is equal to D1 plus D3 plus D5, D7. This is about encoder. Now, this is the, okay, now this is, we are going to, that is encoder, okay, and we are going to discuss about one important thing, one important encoder, that is called a priority encoder. What is this priority encoder? See, when the all inputs are, see here, encoder will operate correct when the one decimal input is high at any given time. If only one input is high at any given time, this encoder will operate correct. If the more than one input is high, then okay, this it gives, if two inputs are active simultaneously, the output produces an undefined combination. So, we are going to solve this one. We can establish an input priority. How to solve this one? We can establish input priority to ensure that only one output is encoded. Okay, this is called priority encoder. So, another ambiguity is also there. Another ambiguity is in the octal to binary. When we are designing octal to binary encoder is that an output with all zeros is generated when all the inputs are 0, right? And the output is the same as when D0 is equal to 1. So, this is the problem. So, what we are going to do? This is we are going to design a encoder, a priority encoder. This is a priority encoder. Here encoder, this is 2 to 4 line, that is 4 to 2 line encoder. How many inputs will be there? 4 inputs. And how many outputs? 2 inputs. So, 2 outputs. Okay. Here how many? D0, D1, D2, D3, 4 inputs are there, 2 inputs X, Y, Z. In addition to this, we are having another output. What is that output? See, that output, in addition to the outputs X and Y, the circuit has a third output Y, right. This is valid indicator that is set to 1 when one or more inputs are equal to 1. When one or more inputs are equal to 1, when one or more inputs are equal to 1, okay, that is set to 1. Okay, when one or more inputs are equal to 1, if all inputs are 0, there is no valid input and V is equal to 0. If all inputs are 0, there is no valid input and so V is equal to 0. That is why V is equal to 0, there are no valid inputs, V is equal to 1 means valid inputs only. So, what is the expression for X and Y? How to write that one? So, the expression for X and Y is the minterms for X and Y are derived from table. This is the previous one is the table, okay, that is the table. So, how to write expression for X? Okay, we have expression that is this one and we have two values. This is how to write this one. This is D0 either D0, D1, 0, 0 like this 1, 2. There are more options. So, how to write this one? This is x is equal to sigma m 1, 2, 3, 5, 6, 7, 9, 10, 12 this days, and next y. So, by using this by using these values we are going to map in 4 variable K map. This is 4 variable K map and we are mapping like this 1, 1, 1, 1, 1, 1, 1, 1, 1 like this. This is the combination. And how to group this one? So, this is 8 grouping is possible and here also 8 grouping is possible, 2 8 groupings, then x is equal to D2 plus D3. X is equal to D2 plus D3. And second one is, what about y? Y is equal to sigma m 1, 3, 4, 5, 1, 3, okay. So, 4, 5, 1, 4, 5, 7 like this. Okay, we are, how many values are there for y? Y is equal to, okay, these are all zeros only, sorry. Okay, these are the values. Okay, the values are 1, 3, 4, 5, 1, 3, okay, 4, 5, 7, 9, okay, 9, 11, 13, okay, 11, 13, 15. So, this is the combination 1 and this is 8. So, the expression is D3 plus, okay, this is the expression. So, by using this is V, and what about V? V is equal to, okay, we can derive D0 plus D1 plus D2 plus D3, and this is the logic diagram for 4 input priority encoder. This is the logic diagram. So, what is X is, what is X? X is equal to D2 plus D3, D2 plus D3, and next y is equal to D3, y is equal to D3 plus D1, D2 bar like this, and the last V is equal to all D0 plus D1 plus D2 plus D3. Okay, this is about 4 bit priority, 4 input priority encoder. This is. Okay, thank you.